Hello, everybody, and welcome to Cloud Native London, March 2021. We are going to just hang out for 15 minutes while we wait for people to join. So feel free to just chill out, listen to some music, grab a drink, whatever you want to do. And if you want to come and chat to some other people in the meetup, then you can go to this link, oisherald.com/r, where we'll be just kind of watching together and chatting. So once again, we'll start the meetup for real at 7 p.m. UK time. All right, hi everyone, and welcome to Cloud Native London. We are a strong, open, diverse developer community around cloud native and the platform and technologies, usually based in London. As with everything else, we are currently virtual. My name is Cheryl. I'm the VP of Ecosystem at the Cloud Native Computing Foundation, which is the home of Kubernetes, Prometheus, and lots of other open source technologies within this space. You can find me at Cheryl. So tonight we have 3 talks. So first off, we have Building Hopsworks, a cloud native managed feature store for machine learning from Jim. Then 7:45, we have BDD plus modules equals your best DevSecOps life from Josh. We will take a 15-minute break after that and then come back for layer cake deterministic security with Steve. And we're going to wrap up at 9 p.m. UK time. But that is enough about me. Let me ask a little bit about you, because we have people coming in from YouTube, we're live streaming to YouTube, to Twitch, and we're on Rambly as well. So if you have a phone or laptop or tablet handy, please go to this URL, oysheryl.com/p. You don't need to download anything. It's just going to take you to a screen where we'll do a little bit of live polling, kind of get to know each other a little bit. So I have 3 questions for you, and then 3 questions on how you are using cloud native. Okay, so oysheryl.com/p. And if you lose this link, there's a slightly longer one you can go to in just a moment. All right, so first question you should be able to see, is this your first time at Cloud Native London? So you should have 2 options, yes or no. If you've come before, then just hit no. If this is your first time, then please hit yes. And I'll give this sort of maybe 15, 30 seconds to start with, because there's a little bit of delay between Zoom and YouTube. So I'll just let people figure out how to get to that link and submit their answers. Again, if you lost it, you could use this link as well, polev.com/CherylHung278. Looks like we are actually about 2/3 of people returning, about 1/3 of people new, which is awesome. This is pretty typical, I would say. We usually have a lot of returning people, which is fantastic. And I love to see just people coming back and hanging out. But if you're part of the 30% that is new as well, hi, welcome. I'm glad that you could find us. Okay, I'll give another just 10 seconds, just to any last minute entries coming in. Okay, I think we are pretty stable. Awesome, awesome, awesome. Let's go to the second question. So second question is, where are you right now? So you should see a map of the world, and you can just press wherever you are at the moment. This is always really fun because, as I said, this is Cloud Native London, but we're definitely not all in London anymore. We're all dialing in from different places. You can also fix things. So if you land in the ocean by mistake, you can undo that and put yourself wherever you really are. This is awesome. I think we've got quite a few people in the UK, good people across Northern Europe, a couple of people in, one person in Africa. This is cool. Again, just go to this link. You can use this polev.com/CherylHung278 on your phone or your laptop. Just see where people are hanging out. I think next time maybe I'll have to blow the UK one up a little bit bigger so you can see exactly where in the UK people are. Oh, this is cool. I don't know does anyone know what country this is? I feel bad not knowing what country this is. Mongolia?
Addis Ababa.
I mean, if you're really in Mongolia, and you're joining, that is awesome. I'm so happy that you've joined us from Mongolia. Okay, seems like, there's still 1 or 2 coming in, but I want to make sure that we keep getting through all of our questions this evening. So what is your job title? Tell me a little bit about what you do. So your options here are architect, application developer, backend developer, engineering manager, SRE/DevOps engineer, security engineer, or anything else. And just kind of pick the one that's closest to roughly what you do. If you are in other, then maybe you could also put into chat or tell people what else you're doing. Others showing up actually pretty strong at the moment. It's like 33%. So I would love to hear what you folks are doing. And SRE and architects definitely taking the lead. No application developers, no backend developers tonight. This actually surprises me. I think this is pretty typical though. SREs and architects tend to be the majority, and then some others as well. Cool. Okay, nice to see those answers. So let's go and find out a little bit about how everybody is using Kubernetes or using cloud native or not at all. And these questions are submitted by our speakers. So the first one, I think, Jim, this is your question. Are feature stores for ML the next big data platform in the cloud? So what do you mean by this question?
Yeah, what do I mean by it? I mean, have you ever heard of it? If you never heard of it, then it's obvious what your answer is. I mean, I think in the data engineering community, it's quite hyped space right now, but I think outside data engineering, it's not particularly well known.
I think that definitely seems to be the case for the audience at the moment. 60+% saying never heard of them. Is this about what you expected, that most people wouldn't have heard of it?
I'm wondering if a lot of the other people who came in are actually data scientists or data engineers who've heard of them. I want to hear more, but I don't know. That's speculation. I don't speculate. A wise man said, don't guess, measure.
Oh, what's the fun then? It's like, I'm always interested to hear like what you were expecting from this and just.
Yeah, well, I had an introduction section on feature stores, so this actually works out quite well. So then the never heard of them crowd can maybe find out at least what a feature store is, and then they can hate them.
Nice. Okay, I'm going to look forward to hearing the introduction about it, because I've got to say, like, I know the words, but I don't know in enough detail. So I want to hear more about it as well. All right, awesome. Seems like the answers have settled down. So plenty of newcomers to feature stores. Okay, second question. This comes from Josh. Do you regularly use BDD in your development flow? Josh, tell us what BDD is.
So it's behavior-driven development, and not to get ahead of myself, but it's a bit of taking testing, making it human readable, but also it's more about building the right thing as opposed to building the thing right. And I'll probably get on my soapbox about that a bit later, but that's interesting that no one uses it often. Maybe I'll get some converts, and that might be good.
Oh yeah, there we go. We're bringing in a couple of yes, often answers. Again, like, is this something that you were expecting, that most people haven't used it or don't use it often?
Yeah, it's not as common as I'd like it to be. I think the very rarely bit is interesting, because I guess I'm wondering why that would be very rarely. If they've used it before, do they not think it was valuable, or yeah, are they wanting to use it but can't? I guess I'm very curious about that.
Yeah, I mean, feel free to comment and just tell people, if you've used it before but you don't use it now, like, why is that the case? That would definitely be interesting to find out. Cool. That dropped to 0 for a moment. I thought someone might have made a mistake and we'd have nobody who's used BDD before, but no, I think we're pretty settled now. So I'm going to go to the third, or actually the last question of the evening. This comes from Steve. So how many of you scan your Kubernetes deployment files for security misconfigurations? And your answers are never, I didn't know I could, yes, I don't create deployment files, or beer. Which seems to be a pretty popular answer, I gotta say, Steve.
I think maybe I was an error adding that in there. Bit of a red herring. Well, judge the others. Wow, it's a tie.
I feel like you definitely understand the vibe of this meetup, though. It's like, yeah, beer, of course.
That's what everyone misses the most. I'm glad there's a lot of yeses and a few I didn't know I could, which take the place of the nevers. So it sort of implies that they would if they knew. So that's good. That's very nicely leading into what I'm going to be talking about.
Cool, awesome. And surprised that no one said I don't create deployment files.
Those are that's the beer crowd.
Yeah, maybe. I'm just like, well, I'm more interested in beer than anything else. Oh, okay. Someone came in at the last minute with I don't create.
Nice. Thank you, whoever you are.
Okay, but definitely beer options. I hope you have some beer references somewhere in your talk as well.
I do.
Okay, I look forward to seeing it. Cool. Thank you everybody for taking part in the live polling. It's awesome to get to know you a little bit and to find out about what you're doing. So that is the end. You can put your phones away now. I want to say thank you to tonight's sponsors who help keep all of this running. So I'm just going to ask them to introduce themselves for a minute. So Mitchell, you can go first.
Yeah, hi. I'm Mitchell, founder of UMatter. We're a technology recruitment company focused in cloud computing, but we were set up to do things a little bit differently. And by that, I mean put engineers back at the center of the hiring processes. We understand how important technology is, but we also understand how important other factors are as well that sometimes get left out, like your growth, continued development, your team, culture, company values, so many things like this. So yeah, if you're ever looking for a new role, hiring, feel free to reach out or just head over to our website where we've got a cloud blog about loads of things you could check out. I'm super honored to be part of the community, so thanks everyone for welcoming us in as well.
Awesome, we're really, really happy to have you here. Okay, next up, Ashley, would you like to introduce Palo Alto Networks?
Sure can. Thank you, Cheryl. First of all, yes, well done, Steve, one of the beer crowd. So you picked right there. Palo Alto Networks, we are known for our big firewalls and all the stuff we do in that space. We're perhaps less well known for all the work we want to be doing more of in cloud native land. What that means is that we've spent a huge amount of money seeing where the future is and buying up a number of different companies. We now have this cloud native security platform that we are very proud of, and we think that everybody else should be as well. But more importantly, the reason for sponsoring this event is we want you to come and work with us. We have a number of open roles. Please do have a look on our website. Come and work with us around bringing security into cloud native. Thank you.
Cool, thank you, Ashley. Humio couldn't send anyone this evening, but they've asked me to tell you that Humio is a time series log management solution for unrestricted event analysis, which scales to multiple terabytes per day on premises or hosted. Lizzie, over to you.
Hi everyone, I'm Lizzie, I'm from Technovo. We're a challenger digital consultancy and we provide expert partnership and growth without creating dependencies or disrupting culture. We pride ourselves on investing in talented developers and working together to provide the best possible outcomes for our clients. We work across both public and private sectors and some really exciting transformation projects. If you want to find out more, just check out our website or on us on social media on LinkedIn or Twitter. And I'll be in Rambly as well after this, so feel free to come and talk to me.
Awesome. Thank you so much, Lizzie. And last but not least, Zan.
Hello, hi there. On behalf of Circle CI, we're the world's largest shared CI/CD platform. My name is Zan Markin. I'm a developer advocate, and we're super excited to be supporting Cloud Native London. And I'm sure that most, if not all, folks here are comfortable or familiar with CI/CD and how it fits well in the Cloud Native workflow. But if you're not, then you're in luck because tomorrow I'm running a webinar on the topic. Tomorrow morning at You can check out my Twitter, it's @zmarken, and you can see how to attend that. And if you are familiar with CI/CD, you might know and understand how annoying it can be to always copy the same sets of config YAML all over and over, and how error prone that can be. That's why we at Circle CI have the concept of orbs, which are reusable sets of configuration that let you easily incorporate jobs and steps for different programming languages or technologies like Docker, Kubernetes, and so on. To learn more about orbs, just search about them for on AltaVista or whatever you use, or of course ping me either on Rambly or on Twitter. Thank you very much.
Awesome. Thank you so much. And once again, thank you to all of our sponsors this evening, without whom we could not put on these kind of events. If you also want to be part of this, then please go to cloudnativelund.com. Our next speaking slots are about November, I believe, 2021. So please come volunteer. We really welcome first-time speakers. You're also welcome to come and sponsor some of these events or promote your own events. And that is it from me. With that, I would like to hand over to our first speaker, Jim. So, Jim, the floor is yours.
Thanks, Cheryl. Hopefully everyone can see my screen here.
That's good.
Minimize this. Great. Okay, so thanks for having me. And my name is Jim Dowling. I'm CEO of a company called Logical Clocks. I am technical. I'm actually also associate professor at KTH University in Stockholm. So I'm based in Stockholm, even though my accent is not necessarily Swedish. So I'm going to talk a little bit about a platform we've been building called Hopsworks, and the journey we've gone on. It's now a cloud-native managed platform in the cloud. It's what we call a feature store for machine learning. It does a little bit more than that, I'll talk about. And hopefully I'll just share some lessons of our journey of really taking this monolith that we built and seeing if we can make it fly in the clouds. And just back to Steve's joke, our logo, you can see at the bottom, it is actually hops. It is it's another beer reference for today. And that is a monolith, by the way, in case you're wondering what that shiny thing is in the middle. So just a little bit of background. What is Hopsworks? It's an open source platform. It's available. You can download it and install it on any virtual machine or any Unix or Linux-based machine. And we released, I guess, the earliest version back in 2016, and then we started a startup in 2018, selling the platform. And in 2018, we were kind of in a fork in the road. We could either, it's a stateful platform, so it has database in there and a lot of state. And we had to decide, will we go and build a fully Kubernetes managed platform, just Kubernetes native platform, or will we build a managed platform in the cloud? And we went the direction of managed platform in the cloud. And you can discuss the merits and others of that approach, but we basically decided that we think, at least for data science platforms and for feature stores, that people do want to consume them as just cloud native managed platforms. Press a button, off you go with your cluster. And there are alternatives have arrived in the Kubernetes world. We have Kubeflow is a very popular platform on Kubernetes for machine learning. So I'm going to talk a little bit about some of the challenges we had and some of the, I guess if you want the TLDR of the talk, it's really that a serverless platform in the cloud is maybe not the best technology to use right now for interactive web applications, but we learned a lot doing it, building it. Okay, I'm going to first introduce what is a feature store for machine learning, and do you need it? Probably you don't, but maybe some of you do. And I'll do it from the perspective of the business, because often you start at a business problem. And this is one you can read about from our website, Logical Clocks. We have a white paper and webinars on it. Money laundering is a big problem. If you want to identify money laundering when you have financial transactions, what you can do is you can use a rule-based system, and that's currently what the state of the art is. And in work with Swedbank, a customer of ours, we trained models to predict if a given transaction is suspected of money laundering or not. So you can see the code on the left is the rule-based approach, and then the machine learning approach, which is based on deep learning, is on the right-hand side. Now, the challenge for that, if you're a bank like Swedbank and like many large organizations, and we have architects on the call will know this, that your data that you want to get to the data scientists, they don't just need to train models, they need to operate them. We need to run this as an operational platform. And the data will be spread out over the organization in data warehouses, data lakes, Kafka, and you need to get that data not just for training, but serving. And of course, in any large organization, there's going to be barriers to getting that data. And that's kind of the state of the art, I guess, in many, in particular in finance and many more regulated industries. This is currently the way it is. It's not easy to get access to enterprise data for training and serving models. So the goal of a feature store from many architects' perspective is that, well, if I have a platform in place where we can have a principled ingestion of data from these different platforms to a central data warehouse for machine learning assets. So we call features are basically the data that we use to train models with and use also to make predictions with. So those features are effectively, you can think of them as being columns in a table if you're a database person, but the feature store is a place where we're going to store all of the data that we've taken from the backend platforms. We've transformed it into, if we have a number, we might turn it into a numerical feature. We might normalize it. You know, we may have a string and we may one-hot encode it before the feature store or after. But basically, we transform the data that's coming from the backend before we start in the feature store. It's not just a copy of the data that you're from the existing backend platforms that you're storing there. But this is a way of integrating the data engineering people on the left and our data science people, and then the ML engineers who serve these and operate these models in production. So how this feature store fits into what we call a machine learning pipeline, which is where you go from your raw data. I'm going to draw a little bit as an academic. I'm also going to draw a little bit on the screen. We have data stores on the left-hand side. These are the ones I mentioned, data warehouses, data lakes, and event buses. And we want to convert that raw data. We call that transforming or feature engineering. And we're going to convert into features stored in this thing called the feature store. And then we'll have downstream data scientists extracting that data to train models. And then the operational applications that are running 24/7, like this money laundering application. Every time a financial transaction arrives, we go to the online feature store, we get a bunch of features, because things like how many times has a user transferred money in the last day or last hour or last week, that won't be stored in the application over here. It'll have to go to the feature store to retrieve that value. And that data will have come ultimately maybe from a Kafka topic here. It'll be pushed into the feature store and then the application can retrieve it. So this is the end-to-end kind of machine learning pipeline. And you'll notice it's not end-to-end, that there's actually two parts. There's one pipeline which goes from the data stores to the feature store, and then you have a simpler pipeline of training models. And that has implications for data scientists, but I won't go through those implications today. Now, we have the feature store actually consists of two parts. It's two databases. It's not, it looks like one system there, but you've actually got something called an offline feature store. It's a scalable database, and it's used for typically creating the training data. You're going to take the existing features in the feature store and then join them together to create training data that you use to train models. And that's what we can see at the bottom here. You can see we have these things called feature groups, and we have Know Your Customer feature group. We have real-time financial transaction data, and we have historical financial transaction data, and we can basically join those together into training data. Now, training data is typically files, so it's stored in a file system or an object store, and you have different file formats. So in TensorFlow, we typically use the TF record file format, but if you're using scikit-learn, it might be CSV or NumPy for PyTorch and so on. And this is just showing the code they would write a data scientist to create this training data. So the cliche is that 80% of the time of data scientists' work is to create training data. Here you can see it's very simple to do that. And this will automatically split their data into different training, test, and validation parts so that they can train and test and validate their models. So that's the offline feature store. We actually support Apache Hive. And in the cloud, we use S3 as the underlying storage layer. But when we're running on-prem, we use our file system HopsFS and a new version of HDFS, next generation HDFS. Now, the online feature store, we have it's a new version of MySQL cluster, a new distribution called RonDB. And it's a distributed in-memory database. It provides a JDBC API. There is a Python API and a Java Scala API. But basically, your applications make these queries on the database, retrieve their individual feature vectors, we're called, or rows, and then they make the predictions with them. So that's basically the features store in a nutshell. And how it fits into the bigger picture of machine learning pipelines. This is like, I call this the Beano Town diagram, because if you know Beano Town, which is this comic in the UK, you can see all the characters on one page. So here we can see everything you need to do to go from your raw data up here to feature engineering, computing the features, training models, deploying the models, and then monitoring the models. But you can see there's lots more lines and boxes because there's a lot of metadata moving around here. You want to have metadata for governance, for reproducibility, for debugging. And there are different ways of looking at this. So many people think, will I go with best of breed? I'll pick one platform for this, one platform for this, for model serving, one platform for training, one platform for experiments, one platform for feature store, and one platform for feature engineering. You know, our take is we provide all of this in Hopsworks, and we think that's the way the industry is going, because there's huge synergy effects by being able to go from your model that's running in production, observing it, monitoring it, finding out the program that trained it, the hyperparameters used, the features used to train it, and you can easily not just reproduce, but debug and govern all the steps in one platform. And it's hard to do that when you keep crossing system boundaries. Okay, so to implement all of this, you need quite a lot of infrastructure. And this is Hopsworks from an architectural perspective. We have a number of systems in here. So you start off and you have your feature store, which is these two databases. It's Hive and RonDB, and the data of Hive is stored on HopsFS or S3, ultimately S3 in the cloud or Azure Blob Storage. And then we have a compute layer. So the compute layer is actually batch. We have Spark, we have Flink, and both of those support streaming, and Spark is for batch. We can also run Python code. So you can run not just normal Python programs, but you can even run notebooks as jobs in our platform. And you can even orchestrate workflows with Airflow, which comes bundled, or you can use your own Airflow. And then we do model monitoring and serving of models by plugging into a Kubernetes cluster. So we currently support TensorFlow Serving Server, Flask, and then we'll support Kubeflow or KF Serving in the next release. So this is, you know, quite and I called it the monolith. This is the platform, Hopsworks, and you can scale it out because we have workers here that you can just add workers, remove workers. You can run the whole thing on your laptop, or you can run it on a large cluster with petabytes of storage. So this is what we built in 2018, and we actually started selling to customers on premise, but we knew that we had to put this in the cloud. You can't just build a platform like this and expect to have a niche where you can just survive on premise. You've other well-known platforms like Databricks and SageMaker who provide a lot of this functionality. Now, one thing we did have that was difficult in moving to the cloud was we had our own security model, and it's quite a unique security model. We call it project-based multi-tenant security. Another way, if you're a security researcher, you might be familiar with the notion of dynamic roles. So being able to change the set of roles that you have at any given point in time. And that's effectively what it does. But let me try and explain it in simpler English. If you have a user Alice here, and Alice is a member of two projects. So we have an abstraction called a project. We have project A and we have project B. So what we actually do is we create a new identity for Alice in project A and a different identity for Alice in project B. That identity is backed by an X509 certificate. And then when Alice runs jobs in project A, she runs with this identity, project A _ Alice. And when she runs jobs in project B, she's running with this project B _ Alice identity. So this user here is not able to access any data in the other project, even though Alice is a member of two projects. When she's running a job in one project, she's restricted to running it in just that project. It can't cross-link with data, it can't copy from the other project she's a member of. So we're effectively being able to change the role she has depending on the context, which project she's active in. This is quite good. You've got kind of this, what we can say it is a sandbox model. Sandboxes are great. You can have sandboxes on a shared cluster, But then obviously people always want to share data between them. So for example, when we have a feature store, we'll typically have a production feature store, and then we might have a staging feature store and development feature stores. Now we can have them all in the same cluster. And what we can do is we can share, for example, the production feature store read-only with a staging feature store, so that you can test out things like joining features from the new staging feature store with the production one to make sure everything works as expected. And then when you're happy with that, then you can migrate those features from the staging feature store into the production feature store. So this was a security model we had, and it ran on premise, and we were very happy with it. It was based, as I said, primarily on X509 certificates that we can see here. There are a couple of edge cases. We could do X509 certificates for our online feature store, which is a MySQL server at the front end. But there are so many different clients that two-way client certificates is actually difficult for many different programming environments. So we provide credentials there as the main way of securing access to it. And then there are one service, Elastic, needs a JWT token, and then we support API keys for clients because it's simpler than two-way certificates. But that's basically the way in which they access the platform. Now we wanted to move this thing to the cloud. So, you know, we had things like LDAP and Active Directory and OAuth 2 support. But what we needed to begin with was we started out by when you deployed a cluster, you would get an IAM profile associated with the cluster. So that meant that any jobs running in the cluster could be associated with an IAM role and could access cloud native services with that IAM role. Now, what we've added recently is the ability to associate many IAM roles with a cluster. So that what you can do is you can say, well, this IAM role 1 is only available inside this particular project. It's only available in the dev store. And in fact, you can restrict it even further. We have a developer, we have something called a data owner within that project. You can say only data owners can access that. And the other role we have is data scientists, who are people who can just run jobs. So you can restrict IAM roles to not just the projects, but also roles within a project. And for external platforms, because there are other, so we have the only feature store in the cloud available on AWS and Azure today. So platforms like Databricks that are available in both, they can integrate with our platform and use our feature store. They don't have a feature store today. And we typically do that with API keys. Is the way. Now, in fact, a Databricks cluster will use more than the API key. It will download certificates because it can run Spark jobs that write directly to our cluster. So it's a combination of the API key to download the certificates, and then the certificates are actually used to authenticate the Spark jobs that are writing to our feature store. Okay, let's move on a little bit then. So we had some decisions to make when we were going to move this platform to the cloud. We're going to the cloud. We're building a Hopsworks cloud native platform. We want to be able to spin up clusters. We want them to be elastic, to be able to, you know, add capacity, remove capacity, stop them, back them up, upgrade them, all those kind of things. And we had some dependencies. Our platform is Dockerized, so we were using open source Docker repo, and we connect into Kubernetes. So as I said, the platform doesn't run on Kubernetes, but what you can do is you connect to Kubernetes, and then you can run jobs on Kubernetes, primarily Python jobs. You can run your notebooks, so Jupyter notebooks or Jupyter Lab notebooks on Kubernetes, and then you can serve models on Kubernetes. So TensorFlow Serving Server, KF Serving, and Flask. So we decided to use the cloud native versions of Kubernetes. So EKS, it should be, AKS. And then we're using also the container registries for AWS and Azure, ECR and ACR. But there are another, we have a bunch of other services in the platform. So we provide Spark as a service in the platform. And, you know, we could have plugged out our own version of Spark. It is our own version of Yarn. It's not standard Yarn. And we decided not to plug in Databricks EMR. We decided our one was good enough, and we liked it. And we have our own file system, HopsFS. And what we decided to do is, instead of replacing HopsFS with S3, which has worse semantics and worse performance. HopsFS is POSIX-like semantics, and what we did is we plugged it into S3. So we took the block layer in HopsFS and we replaced it with S3 objects, and we've written quite a bit about that extensively and published at top conferences about that. We could have also used a cloud-native database as our meta store for our platform, but we didn't. We had this database called MySQL Cluster NDB. And what we did instead was we forked it, and it's called RonDB, and I'll talk a little bit about that later. And we have Kafka comes with a platform on-prem, but we have it, the security model is such that we need our own authorizer for Kafka, and we decide against using a managed Kafka because we can just run it with our security model. And yes, we do need to do a little bit more work in terms of operating Kafka and monitoring Kafka. We do Prometheus behind everything for monitoring, and we do Elk Stack for capturing logs. But we decided that the benefits of keeping Kafka internal exceeded moving to a managed version. And the same is true for Elastic. We're actually using AWS's Elastic Open Distro because it has security built in. So you have access control with tokens, which again fits into our project-based security model. So what that basically means is that, you know, if you run a job on our platform, that job will be able to only write to the Kafka topics inside your project, only able to access the Elastic indexes within your project, and also the files within your project and the feature store and Hive database within your project. So we're actually the first European company. I think we're the only European company that provide a managed scale-out data AI platform. So something like Elastic MapReduce or Databricks. There are some other ones out there from different places in Europe. So it's quite an ambitious undertaking. There's only 27 people in the company, 18 developers, so it's a lot of work. So this is what we released in early 2020. We released an open beta version pretty quickly, and then in November we went GA, and we have customers running on this today. It's called Hopsworks.ai. And what we needed to do was a way to manage these Hopsworks clusters. So how could we allow users to, you know, create clusters like you do in Databricks or Elastic MapReduce, and be able to manage the life cycle of those clusters. So start them, stop them, back them up, upgrade them, and all those things. Our Hopsworks clusters are more heavyweight if you're familiar with Databricks as a platform, which is a way of running Spark in the cloud. They're more heavyweight because we have stateful services. We have this feature store inside there. And then we have some of the other services as well. So this is what we built, and it's not very often actually companies tell you internally what their internal architectural choices are, and I'll talk a little bit about the details of them. So firstly, we have a front end in React, which is fine. APIs are through an API gateway, and we're using Contino for access control or authentication as well. And we're using Lambdas to do all the processing. It's completely serverless, and we're using DynamoDB as our database. It's very expensive. We have CloudFront, and then we're using the DNS, managed DNS service Route 53, because every time you start a cluster, we create a subdomain of Hopsworks AI where your cluster runs. And what we need to do from within there, the Lambdas are doing is they're going to create clusters on behalf of the customers. So in AWS, we have something called a cross-account role. So we need this external role we see down here. We need the customers to actually configure this cross-account role before we can launch the cluster. And Databricks do this as well. It's an established way. On Azure, it's slightly different. You need to have a tenant ID and a subscription ID that you create that allow us to launch within a resource group that you can provide or we can create for you. Now, so what happens is that the customer's clusters, the Hopsworks clusters, run inside their VPC. The AMIs are actually in the customer's account. So if they remove an AMI, we won't be able to get it. And the data is stored in their account in an S3 bucket. So everything runs inside here. All we can do from with our managed platform is we can control the life cycle of the cluster, and we get certificates from Let's Encrypt. It's cheap and reliable. So a little bit about the Lambdas themselves. We have Lambdas to do things like manage users, manage the clusters, and you know, we have there are some events that happen on clusters. So when they start, when they stop, when they come alive, that we need to have triggers for, and this is where our external role allows us to capture those events. But in general, we don't listen to any traffic that's happening on the clusters. And you know, we have then some events we can trigger on the clusters, such as stop a cluster, add a new node, remove a node, and back up a cluster, and so on. We integrate with other platforms, so you can integrate with Databricks, for example, with VPC peering, and the same is true for SageMaker. I think I'll just show you a little bit of it now because I know I have a couple of minutes. So this is what it looks like if you're curious. And I'll get into the criticism of it in a second. You can see the Lambda wasn't warmed up. So now it's taking, a second to present this page, which in web application terms is not really good, right? So, Lambdas as cloud native applications, you can see that Lambda wasn't warm, so it was like 2 seconds to go. And this one is warmed up, so it'll be around the order of half a second. So here you can see we have clusters. And what we can do is we can add workers and remove workers. I actually timed it earlier. We're faster than Databricks. Databricks take about 6 to 7 minutes to spin up a cluster. And we can add and remove workers in about 4 kind of pretty cool. But the spinning up a cluster itself is more heavyweight, takes about 12 to 15 minutes. And we monitor usage in here. So we're doing, we've events to monitor when clusters are started, when the compute's accessed, and how much storage is being used in the buckets. So that's basically the managed platform that we can see there. I'll just go back to the slides. And Hopsworks, we have plenty of videos. You can have a look at it in your own time. What the actual application looks like. Now, when we integrate it with Kubernetes, what we actually do is each project in Hopsworks gets a namespace in Kubernetes. So what we do is for that particular project, we can store an X509 certificate and a JWT token so that the pods that are created and the containers that run on them can access the services in Hopsworks. So if we're doing, for example, model serving, what will happen is we'll spawn a container and it will contain the model itself, and then it will make calls back to the feature store to retrieve features when it needs to build feature vectors to make predictions. And then it can also store logs to Elastic and also to Kafka, because then we can monitor the models in production. So a couple of minutes left. DynamoDB is something we've been using since the start. It's kind of expensive. It's not particularly good performance. It's 8 to 14 milliseconds, and there's quite a bit of variance in the latency of the requests. Getting my team to actually produce reports on cluster utilization and customer usage is very painful for them. And with a SQL API, that's a trivial task. But with Dynamo, it's write a program. It's messy. It's a key value store. You have quotas which you can hit when you're not expecting it. So you're running in production and suddenly your database is not available and say, well, you need to increase your quota. Now, some of it is increased dynamically, but often if you have a spike in traffic, it won't be as elastic as you believe it will be. And then if you have hotspots on particular keys, the capacity of the cluster can be increased, and you're paying for increased capacity that really you don't need. It's only for one particular range of keys where you have a hotspot that you need to handle that. So what we did was we decided, okay, we're going to do something about this. We're going to release a managed cloud native database. And it's a fork of a well-known project called NDB or MySQL Cluster. And our head of data, Mikael Ronström, is the inventor of that database. It's an in-memory distributed database. It's not classic MySQL, which is InnoDB. That's the database engine behind MySQL Server by default. It's an in-memory distributed database. So we had a blog post about it recently. We showed how it outperforms Redis on a single core, but then it scales. It can scale to 200 million ops per second. Mikael is measured at that. So performance-wise, it's very interesting. It actually, we see 4 characteristics of it. We call it LATs, like it has great LATs. It has low latency, so less than 1 millisecond for key value lookups. It has high availability. People are running it with 6 nines availability, high throughput. It can handle hundreds of millions of transactions per second, and then it can scale. You can add nodes or scale up nodes. So this is our online feature store. It's also a product in its own right. So, and the reason we did this was because once you've built one, it's actually, you have the expertise of building these managed services. Adding a new one is not as painful as you might think. Okay, so lessons learned, last slide. Shiny toys aren't always the best. Lambda functions are pretty poor for asynchronous events, anything request response. You can have variations of 200 to 500 milliseconds to 2 seconds. It's not just cold lambdas. You have some, JIT compilation of your JavaScript. JavaScript itself is not great. TypeScript is what you really want to do. Parallel operations are very hard to do in Lambda. Amplify, which is our web application, a serverless web application platform, is not popular on our Slack. In Ireland, we'd call it Amplifect, is a word people say quite a lot. And SQL is a much better API for a general purpose database, not just a key value store. And if you can get good performance and scalability with SQL, we would consider that. I'm not going to do a demo. We would consider it superior. So that's where we're trying to get with RunDB. And I think I'm on time. So it is an open source project, and you're free to go and star us on GitHub. It's just Hopsworks on GitHub. We are a company, and we're on Twitter, and that's it from me. I don't know if there's any questions, Cheryl.
Awesome. Let me bring up.
Or if we have time.
Yeah, we probably got maybe 1 or 2 minutes for questions. So again, if you're watching this, wherever you are, you can go to this link, polev.com/CherylHung278. You can type in any questions that you have for Jim, and we should see them pop up here. But yeah, I feel like I learned a lot. I'm very interested in this RunDB.
RunDB.
Yeah. I mean, I come from a storage background myself, so I'm fascinated by this thing that appears to do everything.
No, when you turn on your phone, there's a 50% probability you're using it. It has a big niche in the telecom space. So, there it's used for, really the highest availability, high write throughput databases that are out there. And, it supports things like geographical replication and so on. But it's like anything, when it's really hard to install and configure, developers shy away from it. But when it's a managed service in the cloud and you can just press buttons and you get it, then it changes the whole perspective on what the properties of the database that are great suddenly become attractive because you don't have to operate it.
Yeah, totally agree. Okay, it seems like we don't have any questions immediately, and I want to make sure that hand over to Josh. But if there are any questions, then I guess people can find you on Twitter. And
yeah, I'll hang out on the page that are on. How does this differ from Feast? Well, they're both open source. We have a UI, and we have an offline feature store, and we do, computation of features and so on. What's the team ratio of devs, PA, QA? Sounds the majority devs. We're all full stack, but we have a dev cloud team, a DevOps cloud team. It's 6 people, and about 8 are. But everyone writes. So we do a lot of. Originally the platform was using Chef and it still is underneath it. So. People do DevOps all the way, everyone. And people do all the way up to front end even.
Okay.
So we were the first open source feature store, not Feast. And that's I just like to point that out.
Awesome. Well, thank you so much, Jim. Really, really appreciate you coming to share everything today. And with that, I would like to welcome the second speaker, who is Josh. Josh.
Hello.
Feel free to take over.
Hopefully that should have taken over. If it's not,
good.
please do shout out. I don't know, that last talk was interesting, especially the points about Dynamo and Lambda. I think we might need to jump on a call, Jim, and go through that because I'm curious how you ended up at those conclusions, but very interesting. So today I'm going to talk about behavior-driven development, which people probably got from the question earlier, but also modules. It's Terraform focused, but CloudFormation modules are a thing as of fairly recently. So you can take this to apply to both, which is always good. It's not quite that specific to Terraform. There's generally 2 key takeaways to take from this, which was interesting, Cheryl, when you asked me for 3, but I already had the slide that said there was 2. But I think the things to take away from this, one is that BDD is about communication. Yes, it's a tool for testing, and we'll get into that, but that's not the reason you use it. And that might be why maybe some people said very rarely as to how often they'd used it in the past. And the other one is modules should be deep, not wide. So when you're building out infrastructure modules for reuse, you need to make sure they are deep. And I'll get into what I mean by that in a bit. So the obligatory about me slide, I'm a principal consultant at Contino. We're a digital transformation consultancy headquartered out of here in London. I've taught BDD and used it as part of consulting engagements for a number of years now. And I'm an AWS APN ambassador, and I'm apparently repping a reInvent hoodie today, but that wasn't on purpose. So BDD. So for those who aren't aware, and I imagine a fair few people on the call might not be aware, but it's where you can take a specification in effectively English, although I'm sure you can write it in other languages as well, but something human readable, couple that with automated tests, and what you end up is with an executable specification. Now, I'm going to use compliance testing as the example because I think it's a really powerful one, especially when you're going on that DevSecOps culture journey, that communication really is key to everything. People that have to suffer me on teams with them know I'll say this about almost everything that we do in tech, because it's really all about communication at the end of the day. But when you think about compliance, and I work with regulated enterprises mostly, and when you think about what compliance is to them, and you think about how many people care about it, it's a lot of people, right? You've got your security teams, obviously. Your delivery teams are tasked with writing compliant infrastructure and making sure that that's working as it should. You've got auditors who want to make sure that you are being compliant. You've got the platform teams who are trying to make sure that everyone's compliant everywhere under their remit. And you've got product owners who need to understand why it is you're taking away their precious engineers' time away from delivering features or fixing problems on this thing called compliance. And this is quite a mix of different people who all have different goals, who all want to achieve different things, different objectives, different incentives. So to get them all aligned around it, you want something that's low friction, that everyone can understand, that works for all these consumers, as opposed to something that maybe the security team can understand, the delivery team maybe does, the auditors are like, I don't know what this is, and the platform owners stick their head in the sand. I've seen that happen. It can happen. And I'm going to pick a little bit here on HashiCorp Sentinel because it's another tool in the space in this kind of compliance testing bit, and a very common thing at every enterprise and any company with a cloud estate at scale is tagging. Tagging is a very difficult thing. I think the general rule of thumb is if you're at 80% plus on terms of things are tagged appropriately, you are absolutely top tier. But how can we actually improve tagging? I've just picked this as the example. Obviously, this can apply to other things. But if we look at Sentinel, and this is outlining mandatory tags, tags you must have on your resources. So if I read this, and I've spent a rather frighteningly large amount of my time in front of code and in an IDE, I can kind of figure out what's going on here. I can figure out that, yeah, it's talking about S3 buckets and EC2 instances. There's some mandatory tags I got to do. And then it's finding all the tagged resources, inverting the list and finding if there's anything left in it. Yeah, I mean, I can get there, but that's communicable to engineers, really. That doesn't translate to anyone else. Auditors can't understand what that means. Product owners can't. Potentially newer devs, especially people that aren't used to maybe Terraform and HCL. Again, it's just hard when really we want this thing to not be hard. We want it to be easy, right? So when you take this to being BDD driven, and the tool that I'm talking about here is Terraform Compliance, which is open source, go and use it. Was written by an old colleague of mine, but it's managed to get a fair ecosystem around it. And I apparently hit the wrong key and went all the way to the end of my slides. So if you give me 2 seconds, that I get this. This is infinitely more readable, I think. I end up with a scenario that says, okay, it says right at the top that I've specified particular tags. And when I've got a resource that supports tagging, bearing in mind that last Sentinel one, I had to list every resource I cared about. This has something built into it. Then it must have tags and it must contain these tags. That's understandable. This is a few lines, but it's very much written in a way that's optimized for communication and optimized for readability. And for all the devs on the call, it will be used to people saying that, you write it once, you read it 10 times. And this should apply to pretty much everything. But really, when you're getting to these kind of tests, what BDD gives you is something that is communication optimized. In trade-offs, I will admit that generally there's sometimes an extra maintenance overhead that goes in. But if we take this as a trivial example and looking at Sentinel again, it's like we can see how you get there. But often it's not just having the tags, it's having the tags at the right value. And I didn't even bother trying to do it in Sentinel because I was already at 30 lines of the last one and I have no idea how I'd even do this. But then I can start to expand on the BDD stuff to something that's still very readable, right? I mean, it's using regexes, so the readability argument's probably sliding slightly, but in here, I can have the fact that there's specific values that I want that are acceptable for these, for owners, Costco's, environments. I can start using regexes to kind of constrain what people can do so they can only put the right thing. Talking recently to people, and some people in the FinOps space were just complaining that people can't spell. Although they've got high levels of tagging, they have to account for every potential typo they could have possibly put in when they were doing the resources to get there. And obviously this gives you the ability to start to lock this stuff down and really kind of drive the right outcomes you're hunting for, as opposed to having some indecipherable code that does enforce things, but no one can understand or rapidly change it, right? And I think when you get to BDD, and BDD can apply to anything, infrastructure, it can apply to your code, it can apply to your front end, anything you want. But these are kind of just some things to keep in mind that I've seen around the place that have really undermined BDD initiatives or just communication generally. Many small tests over fewer large tests. Oftentimes you get this kind of thing, and then you start having like, I want to ensure that my EC2 instance is compliant. And now I have a test that has so many different things it's checking. And now when it breaks, how am I supposed to know what caused this to fail? You know, when you're writing unit tests, they should generally only have one assertion in place. For some reason, once we make this jump to BDD, where we're still doing automated testing, a lot of the rules and heuristics we have just start to go out the window, which can make this really bad. Or often they're taken from manual QA scripts and just converted straight over without thinking about how that needs to change to fit the environment. The other one is the right people aren't in the room. When you're writing these scenarios, you need to make sure you have the right people there. And generally that looks like a 3 Amigo team. So a product owner and a couple of engineers. There's a variety of reasons for this. One is you have 2 engineers, so they will argue with each other, but generally end up at a better outcome. You have the product owner, so they're able to answer questions and explain stuff up front. There's a really awesome workshop in this space called example mapping, which you can use for rapidly really elaborating your tickets and making it a lot easier. But having the right people in the room is critical for all these things. Again, I'm going to hammer on the point about communication, but especially as we've all gone remote through the pandemic, communication and asynchronous communication has only become more important because you can't hit the person next to you and ask them a question. They're on Slack, hopefully, but you've gone and interrupted them. Like, how can you drive this asynchronous communication? And one of the ways is by using BDD across all things, but talking about compliance. And when you start building this framework that allows you to go, are you building the thing right? Is it compliant? Is it doing what it should be doing? Is it secure? And all those kind of things. And you can start to build them into your CI/CD pipelines, which I hope everyone has. And building this in doesn't have to be hard. Like, this is a very common pattern that I've seen and used at a variety of places, but generally you can have a central compliance test repository that gets checked out and run on feature branch pull requests. Simple. It fails, fail the build, make people fix it. But at least it gives you that level of control and that way of that common vector for bringing compliance to every team, not just something that exists kind of in isolation, but something that is just part of how people do things. It's really about low friction, getting the change you want to happen, and enabling teams, not gatekeeping teams, which is another one of my bugbears around the place, working with sometimes security teams where when you're trying to move fast and you're trying to be in a cloud native space and you are doing DevOps and DevSecOps, that generally it's about getting out of everyone else's way and just giving them the guardrails as opposed to reviewing things manually. And people may have noticed that I've worked in the compliance space that this only prevents you from deploying non-compliant infrastructure. It doesn't do anything on the detection or remediation of existing infrastructure, which these are kind of the 3 core activities. And true, but you can pick up other tools for other pieces. The prevention angle, I think, is a really good place to start because it's a stop the rot activity. If you can get it in place, it stops things from getting worse. So at least as you go through detection and remediation, things get better, rather than you're putting all this effort in, but it's spiraling off to the distance at the same time, right? I did write a fairly substantial article on kind of a more holistic view of compliance as code that is not cloud specific, well, specific to clouds, not any one cloud. Sitting up on Contino.io if people are interested. If you're interested in bringing BDD for your compliance tooling, as I said, the tool is called Terraform Compliance. You can Google it, pretty easy to find. And for BDD in general, Cucumber has probably the best kind of reference material in the space. Offer licensed training, which you can buy and run yourself. Very worthwhile rather than build it yourself. So from there, going to jump over to module design, because for me, these two kind of go hand in hand. If I'm trying to enable DevSecOps to the client and trying to build that out, I kind of need these two things. I need my tests so I can scale myself. And then I need this robust module ecosystem and robust module design to make sure that I'm giving myself options for improving things. I mean, I know Cheryl could teach me more than I could ever know about building ecosystems, but generally when I start talking about modules at a client, it's generally about building an ecosystem around them, that it's not one team's job to do this, it's everyone's job to commit back, and everyone generates value from everyone else's contributions rather than sitting with one team. But what I really like from a DevSecOps space in terms of modules is modules enable secure by default. The cloud vendors, love them or hate them, do not generally have same defaults when it comes to security. They're optimized for how can we get you up and running fast, not how can we get you in a secure space first and then enable you. And that makes sense from them. From their point of view, it's about the on-ramp. They don't want to start locking you away with security straight away before you can even get anything of value out. And really, even though I've spent a lot of time in AWS, I don't want to write KMS keys if I don't have to. There's like all these kind of part security services in AWS and just generally good things to do that you cannot realistically expect everyone to know, right? If the best KMS key is one I don't have to write myself, I don't have to rewrite the KMS key policy every single time I want to do one. If I start doing that, I'm going to have inconsistencies, there's going to be errors, and there's not, you know, even stuff gets through pull request review, stuff gets out there. But if you can invest the time once, bake it into the module, so it's the same every time, and invest once, but reap the value across 100, 1,000 instances, this starts to get really powerful. But the kind of a bit where the design of module comes in is we can see the value here of this reuse being able to put the secure defaults in place. The hard part about doing modules is achieving product market fit. And this kind of comes from my time in the startup ecosystem in Australia, but like when you're trying to get product market fit for something, like generally PMF is talked about in terms of a startup, but it's a very valuable concept to think of, especially, I don't like the word entrepreneurship, but effectively you're trying to build something that you want to take flight within a company. This is still a really valuable thing to think about. And I quite like Ben Horowitz's, I think it was Ben Horowitz, said that you achieve product market fit when the product is being pulled from you and you're not pushing it anymore. So really it's that kind of inflection point where your module ecosystem is self-sustaining, self-growing, you're not having to tend to it and push into it anymore, and other people are pushing in. And that's kind of what you're going for. And we can lament about developers all day. I do consider myself one as well. But when you think about the consumers of these modules, generally they're developers or delivery teams trying to go fast, right? An analogy I like to use and when I'm explaining this is developers as lightning. They're chasing that path of least resistance. If you can make things easier for them, they will generally come to you. If you can place the secure default on the easiest path, they will be secure by default, and you really don't have to do much more at that point in terms of helping them build the right kind of infrastructure and use the right things. So with this, I'm going to take some more development terms, bring them back into modules, and kind of say how they need to be combined to kind of achieve this path of least resistance. And modules are an abstraction, and we use abstractions everywhere. Abstractions are the reason that we don't have to touch the electrical circuits in the computer to make it do things. It's why we don't have to write machine code anymore. It's why, at least for the last 10 years, I haven't had to write assembly code again in production. But the point of an abstraction is reducing cognitive load, making it easier for people, like reducing how much I have to understand in order to achieve the outcome I want. And you can talk about it with this kind of model of deep versus wide. And on the left, we have very helpfully labeled deep, and on the right, we have wide. And that green section at the top is how much I need to understand. And the white section underneath is the complexity I've hidden. So if I want to achieve this outcome, all I need to do is understand the green bit, and the white bit, just that's what I get for free. Leaky abstractions aside, but generally that's the idea. And a good abstraction minimizes how much I have to know in order to get it. And when I'm talking about paths of least resistance, that the better the abstraction, the least resistance. The less they have to understand to achieve their goal, the better, and the more likely they are to use it. I mean, developers talk, you know, this library has a really good API, or this library has a terrible API, and those are massively beneficial in growing usage. Like a bad API will just kill a great idea. And with modules, you can't just ditch abstractions and ditch everything that's been learned just because you're writing infrastructure code now. Again, that's kind of with the BDD at the start, like just because it's infrastructure, but it's infrastructure as code, it is code. You should treat it with the same rigor and quality, with the same learnings we've had over the industry in the last 60, 70 years. And when it comes to Terraform modules or CloudFormation modules or any of these kind of infrastructure abstractions, in Terraform, they're variables. So you can inject variables into the module to drive different outcomes. So if you think of S3 bucket in, you can put the name, you can give it a KMS key you want to encrypt the data, that kind of thing. And just to put some numbers to it, because I can't help myself, if you have 5 variables that are binary, so Booleans, true or false, and you've got 5 of them, there is 32 possible permutations of what could happen there. Maybe they all work, maybe some of them are not right, but there's now quite a lot of different options that could exist. If you have 5 variables that have 5 options, you're at 3,125 modules, variations of the module permutations. Where this kind of comes into it is there was a law coined out of Google called Hiram's law, which is effectively, with enough usage, every observable state of your system will be depended upon by somebody, even if it's not something you expect or that you publish, but generally with enough users, someone will have found it and someone will be relying on it, right? So this kind of leads to a point of the number of variables and the size of, like the number of variables you have going into your infrastructure is a heuristic for module quality. It's not a definitive rule, right? Like sometimes 8 could be better than 6, or 25 could be better than 15 even, but generally less is more in this sense. And yeah, for those people who have to suffer my pull requests, they will know I go through every single variable with a fine-tooth comb. Do we need this? Do we need this? And a lot of the time it's because people want to abstract, they want to get rid of complexity, and they think they're doing the right thing by writing modules that cover lots of use cases. You just want to have modules for today, not tomorrow. If anyone's built a system or built a library or built anything with a public interface, you know it is hard to take things back. It is 100 times harder to take something out of an API than it is to add something. So when you're doing this initial design, you need to make sure you optimize for not having to take anything away, or really trying to avoid that. Adding stuff later because a new use case has come up, that's easy to do. But once you've put it out there and someone's using it, introducing breaking changes starts to increase that resistance. People don't trust you as much anymore if you break them, or if you force, a new version has come out and now they have to spend a day integrating it because so much has changed. They're not going to be really happy. And then when you're trying to get them to build this ecosystem and invest, why would they do it? You're making it harder for them. You're supposed to be making it easier. So it's generally, when you're thinking about these things, just because it's infrastructure doesn't mean you can't treat it the same way as code, that you shouldn't treat it the same way as you would anything else. And I've just seen kind of premature abstraction and premature optimization just lose days and weeks out of teams unnecessarily because people underestimate how hard it is to do this well, and they don't spend enough effort on it. And I've kind of touched on one piece of resistance in this space, if you take my tortured metaphor and run with it. But how else can we kind of reduce resistance? I think solid documentation is a big one. I know developers and engineers don't like writing documentation. I'm with you on that, but this is important. And this is, again, looping back into BDD. BDD becomes your documentation of what your system is supposed to do. And it's an executable spec, so it stays aligned, as opposed to having something written in Confluence or maybe a Jira ticket that then gets turned into code. Maybe there's some stuff in the unit test, but the intent gets lost out of the code base. And having solid documentation, having BDD driving how you work, brings your documentation next to your code and links them together in a way that one can't move without the other, which is kind of the impactful bit. Another one is invest into teams. If anyone's a fan of team topologies, if you haven't read the book, go read the book. It's awesome. But it talks about this concept of an enablement team. And that if you're trying to drive change through an organization, you need to operate in this enablement modality. So whether that's sitting down with a team, investing in them, like if you're releasing modules for the first time, or you want to release something, go and sit with the team, help them adopt it, get that feedback loop, get the trust, build the communication up. And you'll notice it's a significant change, as opposed to the very much dictate from on high or hit them with the stick. It needs to be more carrot focused about enabling them. And the best thing about enablement is once you've done it, you can leave them to it and they'll continue to build upon that. But if you're unwilling to invest in them, why should they invest in you at the same time? Because they're operating to different objectives and different incentives than you are. And the last one is just committing fully. If you're going to produce something for public consumption, even if that's public in an internal sense, realize and commit to supporting it for the long haul, like 6 months, a year down the line. If you're going, we're going to release this, you need to plan around the fact that you're going to be supporting it for a while. It's not something you should just turn out and go, yeah, cool, and we'll just maintain it. We don't need to think about this, but it's something you really need to think about. Because if you do it but don't commit fully, you really impact your ability to commit fully in the future. Because people, again, it's like communication, it's that trust and everything else that people have to learn to trust you. Set their expectations correctly and make sure you meet them or exceed them. Don't set up a level of expectation you're not going to commit to actually meeting. And if people are kind of interested in these kind of areas, Hiram's Law came out of software engineering at Google. It's a challenging book, I think, in a really good way. Like, not everything you read there, some of it you can be like, no, that wouldn't work for me, which is fine, but there's some really good stuff in there. And again, at the end of the day, reading something you don't agree with is generally pretty good as a way of just challenging what you think. And on that deep versus wide bit, there is another really good book, A Philosophy of Software Design. It talks about this and goes into a lot more depth. Again, it's a little bit more code focused, but the principles apply everywhere. They're not specific to any one area. So I'll just leave it with those two key takeaways again. One is BDD is about communication, and two is modules should be deep, not wide.
Awesome. Thank you so much, Josh. I feel like I learned a lot from everything that you've just shared, so I really appreciate it. If I can take over screen sharing for a second, I'm going to put up our site again. So Again, if you have any questions for Josh, please go to this link, polev.com/Shaohung278, and just enter in any questions. Actually, Josh, I have a question because I feel like I've seen this BDD approach around for a while. What do you think is the biggest blockers for people for actually adopting it?
I think it's like a lot of things in tech. You need someone who's done it before to stop you from touching the hot stove and burning yourself and just kind of go, wait, no, hold on. You probably want to do it this way first. And I think people generally, they try and their unit testing starts to fall off as they adopt this. And then they're like, oh, but this is like so much maintenance. And it's like, well, yeah, because it's not supposed to be. You're not supposed to test everything through this, just kind of your core workflows and that kind of stuff. I mean, yeah, I've tried embedding it in teams and it doesn't succeed every time, but at least the ones where it does and they commit to it for 3 or 6 months, it stays, it never leaves. Again, if they can commit to it for long enough, it just sticks in the team ongoing after that point.
Okay, interesting to hear. As I said, I feel like I've heard the approach and there's excellent reasons, as you showed, why you would want to use it. So I was just curious, like, why has it not spread more widely or been adopted more widely?
We use Ruby spec, if you know that, Josh. It's kind of, you can write like, if this doesn't happen, then do that. It works really well actually for REST API of the platform.
Yeah, I mean, yeah, I've used them for building REST APIs like financial processing systems and all that kind of stuff. It's just very much, I like being able to, especially now, I'm like, I refuse to give people stuff to do any other way because I'm like, I want to go through this process so you can be properly asynchronous because we've actually got a proper common understanding of what it is you're trying to do up front. Like even like Jira's acceptance criteria is normally like the user story of like, as a blah, I want to do blah so I can blah. And I'm like, that could be interpreted a million ways and I don't have time to check in, whereas this kind of helps drive to concrete examples very quickly. So you know what you're getting. And it's like, in the test pass, I'm happy. You don't need to talk to me anymore. And generally, I find people stop liking talking to me after a while because I don't shut up. So it works.
Speaking of, we're pretty much at the end of time. So if there are any questions people have afterwards, what's the best way for them to get in touch with you?
Twitter, LinkedIn. I'll jump onto Rambly for a bit now. But yeah, I'm on Twitter or LinkedIn around the place. You can normally find me shouting somewhere.
Oh, okay. Okay, you can answer these really quickly. We'll just take a minute from the break. So,
how long have you used this? Years for doing this kind of stuff, behavior-driven infrastructure. Been doing it for years. Probably 3 or 4 now. When BD should don't fit. I don't know. I try and put it everywhere. So I'm probably the best person to ask for not. I guess if you've got bigger fish to fry, that's only my thing. Is like you may just have other problems. Like generally for dev experience, I'm more likely to go after your branching strategy first and getting CI/CD in a good spot, and then we'll talk about BDD. I think it should always be on the roadmap, just whether it's going to fix your biggest problem.
Cool. Okay. Thank you for submitting those questions. We're going to take a 15-minute break now. So, and then we'll come back for, okay. People are jumping these questions. So maybe you can either hang out or you can post them to Twitter and let people know the answers afterwards. So thank you so much, Josh. Really appreciate it. Nice. And Jim as well earlier. Again, we're just going to take a 15-minute break now and then come back for Steve. So just feel free to grab a drink, chill out, hang out. I'm going to head over to Rambly. So this link, oyshow.com/r. And yeah, I hope to chat to you in a few minutes. Hi, folks, and welcome back to the last talk from Cloud Native London. And the last one is going to be Steve. So, Steve, I'm just going to hand it over to you.
All right, thanks. Cool. I'm going to share my screen. Let's make sure I share the correct screen. Lots of terrible things on the other screen. Nobody wants to see those. There we go.
Looking good.
Yeah, looks good. All righty, fabulous. All right, I'll kick right off and hope everything works out. There's it's like there's some live bits. Some I was a bit of a scaredy cat and I recorded it, and some that I'm feeling brave on. So let's pile through. My name's Steve Giguere. I'm a cloud native security advocate. This is Layer Cake. And the idea of this presentation is talking about how we can move security to be more deterministic instead of probabilistic. And here's if I could just get to the screen and change the whatever over and make the click happen. All right. The more detailed introduction. If you're super daring, that QR code goes to my LinkedIn. I'm a total accept everybody kind of guy. Let's be friends. I'm on Twitter there. I have a podcast called Cozy Cast. And you can find that anywhere. It's pretty easy. We just started a meetup, myself and some friends, just based entirely on security for Kubernetes. So check that out if you wish. Pretty easy to find on Twitch. And I'm a beer fan. Maybe you didn't notice that. So if you're on Untapped and you like doing that kind of thing, you can find me there too. I also have a YouTube channel where I talk about beer relentlessly. All right. This is the Kubernetes talk, security specifically. And in order to adhere to the rules of Kubernetes talks, I have a nautical picture. I've got a bunch of containers, and I've got a word cloud, which I stole from Storage OS, sort of appropriate. It's got all the right things in it. And now I'm going to talk about change. So now that I've ticked all those Kubernetes talk boxes, I'm going to talk about changing the way we perceive of security. So you see it went all black. I'm trying to create kind of a scary security mood here just to keep all my security friends happy. I was surprised to how many security people were in the role earlier today, because I have been on here for sure where I was the only person who ticked security. But let's move right on. How do security people think? What do they want? They have a tendency in the InfoSec world, and by the way, I'm picking on you, InfoSec, if you're watching. Kubernetes security tends to fall, for some reason, into the InfoSec world versus the AppSec world, primarily because of its relationships to server and orchestration. So that's they tend to be the people who have to take this kind of thing on. What they're used to is things that create too much data, and they like that in a way, but they kind of have a love-hate because they end up looking for a needle in a haystack. But the flip side of that is if it's not making enough noise, they lose sleep because they wonder if they're missing something. So this is the kind of world and the way their brains work. They do have to make choices about going with simple solutions or whether going with expensive solutions. Do they listen to their developers and use all the open source things? Or do they listen to the salespeople trying to walk in and sell them some big whopping platform and they're wondering if they're getting any value out of it? These are their problems. Their previous world of security was that they had to deal with really having no relationship with developers at all. And so they became very reactive. They just watched servers very closely, looked for the weird things they might be doing, and hopefully patched them when they could, treated them like pets, and then they reacted. But that wasn't necessarily that's not necessarily the best way to do that if there's an option to be proactive. But when there was an option, they quite often don't know how to be proactive, and that's what we're going to talk about today. Probability versus certainty. I think we all kind of like that. If we can definitely be sure that something's going to work out, we certainly would like to do that rather than trying to just look at the likelihood of something or the impact. And that kind of leads us to that relatively well-known equation. If you didn't know it, cool. You've learned that the basics. I'm oversimplifying, of course. But risk is likelihood times impact. And that is where people start to think about, is this risky, the equation? Our first step to try and solve this problem being proactive, a lot of us are already doing it, and that is everything as code. Hooray, we did it. There are many standards, many standards at the moment, and you probably are using one at least of these. You've got your CloudFormation, your Terraform, your YAML, your JSON, your old school stuff like XML. Did I put that on there? I still put that on there. Helm, and then some abstraction layers that are out there like CDK and Pulumi and things that are allowing us to make the creation of these standards of everything as code easier. So we're getting better, but I think just based on the way the world is changing, there's going to be more, probably. Why not? Why wouldn't there be? Why do we want them? Like, we have to kind of tolerate it and become up with standards we like, because without these sort of infrastructure as code or everything as code, we go back to the old world where only applications were code and other things were involved. Imperative commands lead to mistakes. They lead to non-repeatable results. They lead to no change control. There's tribal knowledge involved that we're trying to get rid of, but it's still there, and many other reasons. The biggest problem with all of these things is that humans are involved. We are not to be trusted with our decisions, not at all. We're our biggest problem. So what we need to do is kind of rotate the board. If you're looking at this thinking, what is this, Steve? This is now Academy Award winning Olivia Colman. Like 15 years ago when she was on Number Wang on that Mitchell and Webb look, a made up game show where you just shout numbers and hope to win. That's kind of how security feels sometimes. What we want to do in terms of security is be able to change that equation. So if we can reduce the likelihood by employing some kind of checks early on, and if we can do that by using infrastructure as code, amazing. We can scan for misconfigurations and other things early. Okay, we're on our way. We can reduce impact. Now, I'm not going to get too into this, but I like the idea of leveraging declarative definitions and being able to use chaos engineering and utilize the rather grim, but still used cattle versus pets analogy in terms of Kubernetes and ephemeral objects. And then hopefully we can take the next step to start using infrastructure as code context to our advantage when we determine risk. And that's what I don't think we're doing quite enough of. I think there's room to move in that space. The importance of context. And Cheryl asked if I was going to talk about beer. It's like she's psychic. This is a true story. Back in January, when many people were on dry January, one of my colleagues in our morning stand-up came to me and said, Steve, I feel terrible. I had a beer last night. I cracked. I was like, all right, it's okay. Talk to me, console. And he said, I had this one beer. And I said, well, that looks nice. Lovely label. Tell me more about it. Well, it was a delicious Imperial Stout, American oak barrels, waves of rich vanilla and caramel. I thought, okay, that's it. Look, now that I've seen the detail of it, I see it's kind of a 10% beer there, Byron, just to name, not change, to not protect the uninnocent. And I saw that as an analogy. It's like I have a container with a CVSS score vulnerability of 10 in there, and this looks bad, right? But this is really only an indicator of risk. It doesn't mean it's high risk. And this is, I think, where we get lost in security theater sometimes when we're looking at things and saying, it's a 10, jump on it. We need to look at the deployment of this. Now, he said he had a beer. If we check the YAML for his deployment, we can see that, all right, some interesting stuff there, stuff we already knew, nice description. We got dinner, salad. Salad looks bad. We don't want that. He wasn't prepared. Replicas 3. All right. He didn't tell us everything we needed to know here. Services Prime, that's pretty good. American Gods is a pretty surreal show. You don't really want to start watching stuff like that when you're over 45. So he's got 3 of these over 45 minutes in the middle of dry January. This is all bad. So this is definitely risk. And now that we know the deployment details, we can actually understand that this is something we need to deal with. We need to take these things out of his fridge. It's all bad. But this is what I'm trying to come to. Can we do this more often? I'd like to see us do that. Okay, so we saw the ingredients. We can see the results. Skip to the end. Yes, I made this, if anybody asks. Definitely, no doubt about that. No internet involved. And my layers start at 0 because I'm a geek, so don't question that either. The cloud, the pipeline, the application's friends. I was going to write dependencies there, but it invaded into my photo of the cake, so we're going to have to deal with friends at the moment. The image, the deployment, the context, and then the runtime, which is, of course, is our icing on the cake when we're talking about security. Starting at layer 0, what are we trying to do? Well, we're trying to deploy our cloud, and we're using infrastructure as code to do that, Terraform or CloudFormation. One of the many varieties of things we can use to make that happen. Hopefully, we're doing it that way. Typically, early on, we're kicking out some imperative commands, but eventually, we're going to turn that into something declarative, we hope. And then in order to reproduce that, we can run checks by a variety of free things. Free stuff's awesome. I've named some there. I don't necessarily have preference except for the ones that I found worked quickly and easily for me. Checkout, Kicks, Terrascan, they're all good, right? They all slightly different, but whatever. And then once we've done that and we've deployed, there are tools out there like CSPM. OpenCSPM is free thing. Always try free things first. And then lots of people have other commercial things. Great, whatever. There's always a commercial thing, typically, right? But there's almost always free stuff that you can use to try all this stuff first. And you should always know about what those free things are. Why do we need these? Humans creating code is bad. We know this. Verification prior to implementing is great. But it's interesting that we're kind of advancing on Gartner's new thing of CSPM so that we can actually maintain state, which I kind of like that. That's keeping in with the world that we like to live in so that things stay and imperative commands can be undone if required. We're getting there. It's getting better. So with kind of that in mind, I'm going to see if this works. This is kind of just to give you an idea how easy, I don't like people to have excuses not to do things. So I kind of just flipped a coin and just pick one of them because I've got them all installed. All of these things, if I have a Mac, they all do brew install, so don't have to worry about it. I picked this because I like human readable and machine consumable output, and it's dead easy. If you can see what I downloaded, Terraform AWS WordPress. Don't do that. Don't just Google a Terraform and then start running it. Run something on it just to see how bad it is. And this was the first link. If you Google Terraform AWS for WordPress, you're going to find this is the one. You might look at this and say, all right, SSH, why is that there? If this really is WordPress, that really shouldn't be there. It's on line 25. Stuff like this is super easy. I can already see it down there. So I can go down, I can delete it, I can get rid of it. And I'm doing this rather slowly. Done. So I can run a scan and I can see that it's gone. But the idea of deploying things with really obvious bad defaults, there's kind of no excuse, because this stuff's like, doesn't matter which one you use. They all just present it with different flashy colors. It's easy. So what are the pros of doing these things? These pre-flight checks can mitigate the risk of obvious cloud infrastructure weaknesses. Yeah, there'll be some weird complex ones that maybe we can't foresee, but we're not going to get caught out on that low-hanging fruit, which is easy. The fact that we're creating declarative definitions is awesome because we're chaos engineering friendly, which results in the reduction in a dependency on tribal knowledge. Hurrah. What are some of the cons I just want to talk about in terms of infrastructure as code from scratch? Is that it's not often not from scratch. Usually you go off and get somebody else's and you start changing it. So it's worth checking all of it to be sure. And also it falls into a lot of the category as just regular old code that I used to write for applications. You can cut and paste it, you Frankenstein it together into something and you hope that it's exactly right. The other thing, which I only just saw an article on from Matt Fuller, who is one of the CloudSploit founders, he was talking about a new kind of attack vector, which is template squatting. So if there's a really popular template out there, the same thing that happens with images, where someone sees a really popular image in Docker Hub and pops one up there with an L for an I to try and trick people into using it, that's actually starting to happen now. So do be careful that if you think you're using one you know and trust, that it isn't something changed with modified trust boundaries. A con. The other one, which is more operational, is that because we don't have that feature-driven change to application code with our infrastructure as code, it can age and fall behind our cloud providers' requirements. So be careful and we can be less attentive to updates. So that's more of a side bit of advice. All right, securing the pipeline, layer 1. I don't like to pick on companies in talks unless they're in the news at least 14 times before, and there's no way you haven't heard about this. I was doing a podcast back in December, and we were talking about SolarWinds back then. And we decided not to talk about it because it wasn't going to be published until January. And we thought, we'll look way behind by when that happens. Nope, heard about it just last week again. It was interesting how that happened. I mean, it's complicated. There was a really great article released by one of the guys from CrowdStrike about it. And it's essentially looking at the provenance and integrity of the software supply chain. And I'm not talking about bringing in third-party things. I'm talking about your internal supply chain. That's really hard to keep secure. And it's one of the least least, well, the least amount of attention is paid to it. That's what I'm trying to say. But if you can get access to the internal CI/CD pipeline, you have the keys to the kingdom, right? So how can we try and look at this? Well, there are tools out there to do it. And I'm asking for feedback on this one. If anybody watching knows, like Intode is really good. Go there, go to that URL and check out how this works. And it's super easy to work out that if you know all the pieces that are going in, you know all the pieces going out, and it's all being watched. Fabulous, right? It's great for it. There are other tools in that space, but there are free stuff that can mitigate problems like this and probably would have stopped an attack like that. The cons, actually kind of hard to do those kind of things at scale. Easy to do in the demo, but at a monster size to make sure everybody's taking part can be difficult to make happen. There isn't a lot of really good benchmarks or use cases for it or stories around it. And I don't think there are. This is one of those exceptions to the rule, commercial solutions that solve this problem. I've not run into one, but doesn't mean it's not out there. So please do feedback if you know of one. Layer 2. This is probably the one we're most familiar with because this goes way back. Like people were making tools for this. Lint, like the first ones way in the 90s. Now we've got a fancy name for it because it's an AST. I started into this when it was just called static code analysis. Now it's static application security testing and the code pipeline. Pretty fancy. You can see that I've pushed out IDE SAST because I'm starting to feel that's more important than what we used to call SAST, which is directly in the pipeline, but I'll mention why that is. Why do we need it? Once again, humans making mistakes. And back when I used to work at a SaaS company, we had a lot of hands-on data around scanning GitHub essentially. And it was about 1 in 1,000 lines of code had some kind of bug or insecurity. If you just take everything on a massive scale. And it's pretty easy to hit 1,000 lines. And I mean, because if you create 500 lines and you back up by 200 and create another 300 with a resulting 800, you've still done 1,000 lines. So it's pretty easy to create a result where there's one little thing wrong. What's good about it? Open source are available, and lots of SaaS open source, like Guardrails is super cool. I just saw a demo of Deep Code. What's the other one? Sonar Cloud is now there, and they all plug into GitHub, and they all do a lot of the new modern languages. They do an okay job of some of the modern languages, but they do them, right? Cost benefits of running one of these tools are huge. And it's becoming easier to do because finding things, I used to find, but I have written many bugs and I hate getting them back from testing. I hate it more if it's support. I hate it a lot. I've never had it been a breach or anything like that, but pen test, it's just they give you this obscure definition of what went wrong and somehow they think it's your fault. Forget it. I'd rather find it early. One real benefit that we don't talk about very often, I don't think people who even the commercial solutions say this enough, is that's one of the rare ways that you can virtually walk all your code paths, even the really weird ones. So even if you run static analysis at a band on a slightly larger code base, little code bases, maybe not, but bigger ones, if you have them, just occasionally, it can be really beneficial. The cons of static analysis, it has a bad rep. Slow, disruptive, false positives. Now we're getting past that. Some of those things, some of those tools I've got listed up there, like Guardrails, Deep Code is pretty fast, are working on that, but the reputation is going to be hard to shake off. The implementation is difficult. And now if we're talking about a microservice development, now we have introduced a diversity of tech stack within the same application. So getting a single solution for that is going to be really hard. So this is why I was talking about why it would be better if we had better IDE integrated solutions that were catered directly to the code that we were using at that moment. VS Code's great for that. There are some out there. ESLint is good. And I think actually Deep Code has one, but I'm not 100% sure on that. But the more we do that, the more we focus on the speed at which developers move, the better we'll be. But I think there's work to be done there. And the last one is that there is limited reach in the next-gen languages. Where often if you're using something cool and awesome, like Go is probably the greatest example of it. There's not a whole lot going on in static analysis for it. I've got the little GoSec guy up there because he's awesome. Securing the supply chain. This is slowly becoming one of my favorite ones, up with layer number 4. The software composition analysis is what it's called, SCA, if you didn't already know that. Something I imagine a lot of you did. We used to call it just dependency checking. There are open source solutions for it, which is great, but they tend to be for older languages. NPM now has it built in. That was a couple of years back, but still cool. There are commercial solutions out there. Hurrah. Commercial solutions are often good, if only for producing very cool reports, because all of them largely settle on the fact that most code is about 80% open source now. And open source vulnerabilities are known to the bad guys as much as they are to us. So let's do the same work that they're doing just to make sure that we're not introducing something obvious in our applications as a result of bringing in dependencies that are potentially out of date or have critical vulnerabilities. We can do that. Not that hard. The pros, find the easy stuff in an easy way. Low-hanging fruit. The cons. Well, this is, I haven't really called it out specifically, but this is kind of where humans come in again. We have a tendency sometimes to bloat our dependencies because while we don't always know the dependencies we need for when we start something. So we start bringing things in that maybe we need now, but we don't need later, but we don't necessarily sanitize that. We're getting better. I'm getting better, at least. And so if we see a vulnerability in a dependency, we don't know if it's used necessarily if we just rely on this data. And even if it is somehow used, we don't know if the vulnerability itself is accessed. So that's a bit of a shortcoming, and it can result in a lot of noise and a lot of false positives. And if that data is going off to a team of security people whose job it is for this elusive thing called vulnerability management, it can be a bit of a pain. And I've got a little stat up there, like 15,000 vulnerabilities released a year is not a good number, right? And that's low number. That's because I'm factoring older years that are smaller just to make that look prettier. All right, layer 4. Securing the image. And I'm going to watch the time. I'm doing okay. Finding known vulnerabilities in the base image and dependencies and in package managers. I don't know of a lot of the free ones that look at package managers. A lot of free tools are great for looking at base images and obvious dependencies that are present from like a user operating system space level. But some of the more commercial ones do also kind of do the SDA thing, because it's pretty easy with things like Node and Python to just look at it and go, well, let's check those while we're at it, right? In which case you get even a bit of crossover into the SCA. So sometimes if you've got a good image scanner, and depending if you've got small code bases, like in a microservice environment, you can actually use that as a substitute for an SCA solution, which is cool, right? If you're getting tool fatigue, which is a bit of a thing. Additionally, you can find things that check for Dockerfile best practices. Like I've got some like a really kind of straightforward one there, like using add instead of copy. And then one that most people I hope know is that the default user can be root, so don't do that. So defaults can be dangerous. And because users do introduce user space operating system dependencies with critical vulnerabilities, you really should do this. This is probably the first one I'm getting to where I'm going, you kind of should do that. But let me give you the pros and cons of it, right? Although it is easy, and there's a lot of stuff coming out that makes it super easy in both in CI and on the desktop, and it teaches best practice, it does some SCA, there's lots of free stuff. We are in danger of becoming security theater in this case, because in my experience, people start scanning images and they scan, then they go to the registry and they go, look at the registry. It's got all sorts of images in it. And that's not at all clean, that registry. There's all sorts of old stuff in there and new stuff and what's going where, who knows. And so they scan that, and then that turns into this incredible amount of vulnerabilities you don't know how to do with. So you've got to be careful that when you're scanning images, you have a system in place and you understand that the life cycle of an image is quite short. So think of the context in which you're doing that, so that you don't end up going down a road that could be a bit of a vulnerability management disaster. So on that, this is where I'm going to try something. I'm going to use the one that I'm most familiar with. And if you know my history at all, the reasons will be obvious. Trivia is really easy. And something I didn't know about Trivia, actually, I just found out, is that you can scan file systems and repositories. There's lots of options to quiet it down so you get clear information. And it's easy enough. Now, this is where I'm cheating, because I was afraid this wouldn't work. And sometimes downloading the database takes a bit of time. So I recorded this. And this is me checking 313. And I was kind of surprised because I thought it would be clean. It's like the latest, and it wasn't. It has an unknown classification vulnerability, but there is a fixed version, so I could have done something about it. So I was putting my developer cap on. I thought, what would I have done there? Because it was unknown. That's a strange classification of vulnerability, but I could fix it. So maybe I should just fix it and we're good. because there wasn't a new version yet. And that was a bit weird. Now that's like a couple days ago. So just to be sure, I tried it again before this. And now there's a 2 out and it's clean. And it's now classified as a high. So I just happened to catch that when I recorded it, when it had been released, but wasn't classified yet. And it was like, as if I caught that as a developer, my head would have exploded. I might have fixed it. But there's like a plus minus on this is really easy to check base images and make sure you're not introducing anything super bad. But there are those moments where you can be given something that is thoroughly confusing. And I can even give you an example that I don't have here that I sometimes do if I have more time, is I scan the latest Nginx because there's a critical vulnerability in Nginx, only one from 2019 that has no fix. And as a developer, if you look at something like that, it's encouraged to try and do that, but it's very difficult to know what to do if you see something like that. So another one of the sort of plus minuses on there. All right. We've got how many layers so far? We're moving all the way towards the end, and we're almost there. And I'm going to try and talk about risk context. And this is where I'd like to see us move. And I know you're going to, somebody watching will throw this back at me and say, Steve, you do it. But when we start talking about securing the deployments, and we typically think of best practices for Kubernetes objects, right? Operational risk, security risk. You can run really easy, cheap checks for doing that. And why do you want to do that? Once again, like Docker files, defaults can be dangerously insecure. But what's kind of something I'm trying to work towards is how can we bring the context of that to vulnerability management? The good news about this is that lots of open source tools are available. It seems like a crazy number of open source tools are available doing this. The first one I ever heard of was Checkoff, and then, of course, I work for a company that came up with kubeliner, and then Kix is out there, and kubescan, and then Andy Martin's got this kubescan is his. And so there's many, and they all just print out the same data kind of differently, to be perfectly honest about it. You can use whatever one you want. The easiest to demonstrate the one that I've been most familiar with absolutely lately is kubeliner. They're super easy. You type it in, an example of this, and this is interesting because, and I'll explain why in a moment. Looking at the checks of kubeliner, this is one bit of kubeliner that I liked, and that is they have a bunch of checks and they're not all turned on by default, because there's a bunch of super pedantic checks that, rather than flood you with a required label owner, stuff that you may or may not have, you have the option, they're already built in to turn them on and be a bit noisier if you want. So I like when checks do that rather than show you like all of the results. After that, it's pretty straightforward. I would have preferred if they went with scan, because I guess that's me, but I created one called email service rushed, and it's missing things that are pretty standard, CPU and memory request limits. And I like that it gave me a bit of learning. It took me to the Kubernetes docs, so that if I thought, I don't know what you're talking about, I can go there, I can go, all right, so I should have a security context. All right, I guess I'll add that. Cut and paste, solve my problems. And you could do the same thing. The data is there for CPU and memory requests. And then rather than you watch me do it again, you just get to see the one I fixed, and there's no errors. Fabulous. I've got the bare minimum of security in place. You can see the difference between what I did before and after. What's kind of interesting about that, if you're doing, I don't know, I'm getting in trouble for saying this. If you're doing the CKA exam and you're producing YAML on the fly with create, and you create deployment, and then you just do the image, and then boom, you get a template. There's no security context and there's no CPU requirements. So you might get in the habit of not having those pieces there. And this is the kind of way you can catch yourself out on going, oh, right, yeah, I need to add, like for real, I need to add those in there because they're really important. So when you get accustomed to those kind of quick ways of producing declarative definitions, you can fall into that trap. This is my little caveat on some of the new abstraction layers really quick. And that is, and this exists just for creating code for the browser as well. If I've got this example where TypeScript is generating YAML, and if I scan the YAML it generates and there's a problem with it, how do I translate that back to the abstraction layer? That problem exists in TypeScript generally. So if you produce code that runs in a browser, you scan it and it's got an error, how do you translate that back? There are mechanisms to do that in that world now, but not so much in this world. So super fast caveat on that one. All right, so a few open source tools combine image vulnerabilities with deployment context. And this is I think I want to start a project for this, because I would love it if something like Chekhov or Kublin or whatever, the images are there. They're listed right there. So why aren't we kicking off a Trevi and making all that happen in the same space so I could characterize the deployment's risk with the vulnerabilities? I would love to make that happen. Nothing does that yet. So there we go. Anybody want to join me in making something that does that? I would highly welcome it, because we would be able to have the context of the beer can again. I would know if that CVSS 9.8 is in a backend with no external connectivity, not running as privileged, versus my 7.6, which is in multiple front-end services with a load balancer and exposed ports and all the wonderful things around that. So that is something that I would love to work on that doesn't quite exist yet. But if it doesn't, I'm wrong, please tell me. All right, I'm over by 1 minute, but this is the last bit. I'm just going to talk about the icing on the cake. And rather than the old world of being probabilistic, we've got some really cool stuff in this space now that we shouldn't rely on, but we still require. Anything using eBPF right now is rocking. I love it. Falco, Tracy, Cilium, like you've got runtime, you've got networking, everything's based on it. It's pretty great. We can find anomalies. We can see it in Kubernetes context. It's awesome. OPA, prevention, and mission controllers, all this stuff is awesome things. We need it, but let's not totally rely on it. Let's run pre-flight checks so that we don't have to rely on the emission controllers. Let's make sure we're doing the best we can with vulnerability placement and replacement so that we're not relying on anomaly detection. But when we have it, we're presented with context that allows us to act on it sensibly. Well, the obvious pros is that when we talk to InfoSec people about runtime, they know what we're talking about. It's a great safety net, but keep remembering runtime can still be reactionary, expensive, labor intensive, and be part of that whole spotted door closed. Here's a bunch of takeaways. Open source is good. Shift left is hard work. Shift everywhere is better. And that's what I was kind of saying. If we do the bare minimums at every layer, then no layer feels like hard work. Context is a huge advantage, and I'd love to see us work more on that. And everything as code is a great answer. Everything is code. GitOps, Kubernetes, less imperative, less tribal knowledge, more deterministic, less probabilistic, and we can all do all of that through Kubernetes. So that is the end. I apologize, I'm 2 minutes over. There's my stuff again, because I'm a narcissist. And I'm done.
Fantastic. Thank you so much, Steve. Really appreciate it. And I love the fact that you brought the beer back in and you're advertising your Beer Native TV channel. So I think I'm going to go have to check that out for sure.
Cool. Thanks. Should I stop sharing?
Yeah, please do.
All right. There we go.
Cool. Well, thank you so much, everybody, for joining tonight, whether you joined us on YouTube or Twitch or Rambly. I'm going to head back to Rambly myself for a couple of minutes just to hang out and chat to people. But that is it for this evening's Cloud Native London. Thank you so much. We'll be back again on the first Wednesday of April. Take care and have a good night.